Good evening, all of you.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, all of you. Exercise 4. Magnetism.
Sir,
Question number 6B.
sir, question 3.
दोनों सुनाई नहीं दिया मुझे.
Sir, question 3.
So question 9.
So question
Sir,
number
question-
6B.
5 or 9?
9. 10A.
14,
12.
27, and 28.
Or 16 diagram.
30th
35.
and 42nd.
So 19 and 22.
31,
Sir, 22.
35.
42.
Sir, 33.
So 7 and 17. 17 also.
26 and 34.
42.
So 24.
So 39.
So 37.
अरे यार क्यों उल्लू बना रहे हो यार. इसमें से आधे से ज्यादा प्रॉब्लम्स क्लास में किया हुआ है.
कुछ के आंसर से थोड़े डिफरेंट है, मतलब डिफरेंट आ रहा है, रॉन्ग आ रहा है, वही है कुछ क्वेश्चन.
क्या बना रहे हो.
जैसे 6 के बी में सर मतलब आई पे माइनस साइन होना चाहिए आई वाले का.
हाँ उसका आंसर रॉन्ग था.
Question number 3. Find the magnetic induction at the center of a rectangular wire frame whose diagonal is equal to 16 centimeters and the angle between the diagonals is this. The current flowing in the frame is this. See how unfair question this is. You are being given rectangular wire frame with angle between the diagonals. So if I drop this, can I get alpha and beta? So because of that, will I get the magnetic field here? Mu naught I by 4 pi, I'll take this distance as b. Sin alpha plus sin beta. How can this be a doubt? I don't understand. They gave you this complete angle. All you have to find out is alpha beta. Half of this length is d. Seven. A very long wire carrying current of 5 amperes is bent at right angles. Find the magnetic induction at a point lying on a perpendicular bisector to the wire drawn through the point of bending. Angle bisector, find the magnetic induction at a point lying on a perpendicular to the wire drawn from the point of bending. A long wire carries a current of 5 amperes, is bent at right angles. Is bent at right angles. Now listen. Find the magnetic induction at a point on a perpendicular to the wire drawn through the point of bending at a distance of 35 centimeters from it. That means he needs the magnetic field here at 35 centimeters. He needs the magnetic field here at 35 centimeters. This point will be a semi-infinite point for this wire. Do you agree with that?
Yes, sir.
Because of this wire, magnetic field here, because of this wire, if I take this to be X, this to be Y, this to be Z, because of this magnetic field here, this 35 centimeters I will take as D, right? So magnetic field here will be in the down, vertically downwards in the plane of the board. Do you agree with that because of this?
Yes, sir.
So semi-infinite wire, because of this it will be mu naught I by 4 pi d. D is given as some 35 centimeters. Play careful with the units. Now come to this particular wire. This wire, magnetic field will be circular this way. So the field will be towards me. This was minus j cap. Now because of this wire, it will be mu naught I by 4 pi d minus I cap. If this is the wire and this is D, because of this wire, magnetic field lines are circular. At this particular point, they'll be towards me. Towards me means minus I cap. Right. Take the resultant of these two, the job should be done.
Yes, sir.
I told you, whole of this game is 3D geometry. There is nothing new in the semi-infinite wire of this and this. You agree with that? The physics involved is only this formula for semi-infinite wire. You should be able to see the 3D geometry. What did I rub away here? This is 26 or 16?
I think 16 किस 26 उसके बाद में नीचे 26 भी
Okay, just now I discussed the 6th B. I didn't discuss 6th B.
सर 6b में सर ये डाउट है कि सर वो माइनस आयोटा होना चाहिए ना लाइक मतलब डायरेक्शन में इंस्टेड ऑफ प्लस आयोटा जो दिया है
4 long wires each carrying current I as shown in the figure are placed at points A, B, C, D. Find the magnitude and direction of force per unit meter acting on the wire at D. At D, आपको डायरेक्शन पे दिक्कत है जरा देख लेंगे.
नहीं सर आंसर मतलब मेरे को जो आया उससे माइनस आ रहा है आयोटा हो
अरे डायरेक्शंस तो देख सकते हो. This is a dot. This is a cross. Now this is D, am I right?
यस सर
And it's a dot. Cross is inwards, dot is outwards. So these both there will be repulsion.
यस सर
These both there will be attraction. These both there will be repulsion.
हाँ सर तो उसमें आंसर में सर माइनस नहीं दिया आयोटा में माइनस नहीं दिया रॉन्ग है
It's okay. I'll make the change.
ओके सर
Nine. Non-conducting sphere of radius r, charge uniformly distributed, sigma angular velocity, magnetic induction at the center of the sphere. Non-conducting sphere, sigma is given. So consider an elemental ring. If this will be theta, this will be r d theta, this will be r sin theta, this will be r cos theta. Because of the charge on the ring, what will be the magnetic field here? Mu naught I Radius square, our formula was a square 2 into a square plus x square to the power 3 by 2. Substitute. How do I substitute? I dq by t. What is a radius? R sine theta whole square upon 2 into a square is r square sine square theta plus r square cos square theta to the power 3 by 2. This is dv. Now, dq I can substitute charge per unit area into surface area of the ring. T is 2 pi by omega. Mu naught charge per 4 pi r square. Sigma is given. Why do I substitute that? Sigma into 2 pi. Radius is r sine theta into r d theta. This is r square sine square theta upon 2. This will be r square to the power is r cube. Now t is 2 pi by omega. अब इसको इंटीग्रेट कर लो, d थीटा बगल में रख के सिंप्लीफाई करके इंटीग्रेट कर लो. 0 to pi, theta is 0 to pi, you will get the magnetic field. Whole of the game sphere is rotating with an angular velocity omega. So 2 pi by dq by t is the current in it.
सर सर अपर हाफ ऑफ द स्फीयर की वजह से फील्ड का डायरेक्शन क्या?
क्या पूछ रहे हो? Current carrying wire, current is in this direction, above and below. Don't you think magnetic field is in the same direction?
Yes.
If this is a ring, you are asking me, here magnetic field and here magnetic field, will they be in opposite direction? Magnetic lines of force will go like this. Oh bhai sahab, magnetism ho gaya.
सर ये शेल का निकाला है क्या?
भाई साहब सिग्मा दिया हुआ है तो शेल का ही करूंगा ना. सरफेस चार्ज डेंसिटी, sigma is surface charge density, so charge is there only on the outer surface of the sphere. I have no choice. क्वेश्चन में सिग्मा दिया हुआ है, रो देंगे तो चार्ज पर यूनिट वॉल्यूम, देन आई विल थिंक ऑफ ए सॉलिड स्फीयर.
यस
सर लॉन्गिट्यूडनल मास डेंसिटी मतलब मास पर यूनिट लेंथ का.
Uniform current of density J flows inside an infinite plate of thickness 2d parallel to its surface. Uniform density of current of density J flows inside a uniform plate of thickness 2d of thickness 2d. Find the magnetic induction induced by this current as a function of distance x from the median plane of the plate. Magnetic permeability is assumed to be equal to unity both inside and outside the plate. If you want the magnetic field outside, don't you think I already calculated this mu naught lambda by 2? किया है कि नहीं? कुछ तो बोलो.
Yes, sir.
In any batch did I forget? वो बता दो. यहाँ पर मैग्नेटिक फील्ड ऐसा होता है म्यू नॉट लैम्डा बाय 2. आई कैलकुलेटेड करंट पर यूनिट लेंथ, उसने थिकनेस भी दिया है. व्हेन आई टुक करंट पर यूनिट लेंथ. व्हाई? बिकॉज़ आई टुक थिकनेस नेग्लिजिबल. हियर J is given, thickness is given. J is given, thickness is given. Right? Now, inside अगर आपको चाहिए तो please observe this. If you are taking inside, now that is outside. Inside, assume an ampere circulation like this. Here also the logic will be the same. You are taking this as x. So the other side also will be x. I'll take this length to be L. Right? Closed integral B dot dl is mu naught. I is the net current in this. How do I get the net current enclosed? Current density. J is current per, J will be current per unit volume here. Uniform current of density J flows inside a infinite plate of thickness, right? Per area of cross section J. That means I should calculate this area of cross section. J is L into 2x. This is the net current flowing through this area of cross section. I took J is current per unit area of cross section, the original definition of J. So what is this area of cross section? Length into this distance is also x, right? B dot dl is mu naught this. Now this will be plus bl, this will be minus bl. 2 times bl, mu naught jl by 2x. L will get cancelled, 2 will get cancelled. Mu naught jx is the magnetic field inside. Exactly the same way you can do it for outside.
So I got disconnected, but you assume that the magnetic field is horizontal inside for the same reason you assume that it's horizontal outside, right? Okay.
Exactly. Because there's infinite large plate.
Yes.
How can somebody ask 19th question as a doubt? I don't know. Didn't we do 19th in the class in every batch?
Yeah, sir, you did.
Class notes में भी है यार. 19th question तो पढ़ लो. 17th also I have done in every batch. Is there any batch in which I have not done 17th in the class? Please speak. 17 क्लास नोट्स में है भाई साहब. क्लास नोट्स एक बार खोल के तो देख लो. If I have not done in any batch right now, please see your class notes and tell me I do it again. Yesterday we learned that in one of the batch I didn't calculate the something magnetic field inside a solid non-conducting cavity. We did it. Same applies. 17th in every batch I do. This is an infinite long wire. You consider an element here at a distance of x of thickness dx. Can I find out the current in this? Total current is I. In this I by b, if the breadth is b, into dx. Now force per unit length between these two to be integrated. Did I miss this in any batch? क्लास नोट्स में है. एक बार क्लास नोट्स खोल के तो देख लो.
So, sorry, sir. I think I wrote wrong in my class notes. That's why.
12th I discussed 14th.
Sir, 18th, can you just draw the diagram for the angles? 18th, sir.
Now, which batch are you from?
Flag 2, Andheri.
Flag 2. You deserve a punishment. क्लास में किया हुआ है। किसी भी बैच में कोई भी प्रॉब्लम भूल सकता हूं मगर ये प्रॉब्लम कभी नहीं भूलता हूं। 18, this is the wire and this is the wire. Didn't I deal with this in the class course? This is 30 degree and 60 degree.
Sorry, sir. This is just, yes, it's just the diagram bit I got confused in.
Punishment क्या लोगे भाई बता दो। $5 5 years down the lane. लिख लो।
Done, sir.
16. Direct current flows in a straight long conductor whose cross section is the form of a thin half ring of radius r. Same
Oh, you
current.
skipped 14.
Pardon?
You were supposed to do 12 and 14. You rubbed it off the board, then you asked the doubt.
14.
You did.
क्या बोलूं? सोलिनॉइड का x वैल्यू चेंज किया है इसमें बस। You are telling me to consider an element from here. A long straight solenoid cross sectional radius is r. He just played with the variables here. A direct current I flows through. Suppose that x is the distance from the end of the solenoid measured along the axis. Find the magnetic induction on the axis as a function of x. Now, magnetic induction here आपको चाहिए. Right? You want this magnetic induction somewhere here. Consider an element.
So this is basically semi-infinite, right?
As simple as it. For semi-infinite, the limits are 0 to infinity. That's all. Only thing is that playing with the variables. They are asking you to take this as x. We are in a habit of taking this as x. So this side will take as small r and thickness dr. That means what will this distance be? R minus x. You want the magnetic field here. dB will be mu naught I r square by 2 into r square plus r minus x whole square to the power 3 by 2 into n dr. Zero to your integral limits of r will go from 0 to x. You wanted some arbitrary value x. R is 0 from here to call this x naught if not. So you will get it as the distance of x naught from an experiment. 0 to b. Did you get the logic? He just played a very
Yes, sir.
simple cheap trick by playing with the limits. He is
Yes.
asking you to take this distance as x naught. Right? Or take it as x only. Don't even change the symbols. You will consider an elemental. We are in a psychological mental block of considering an element at a distance of x of thickness dx. Now he used x for a different parameter. So we get confused. This distance is r minus x. So least value of r is 0, maximum value of r is x.
Yes, sir. So
Right.
magnetic field outside a solenoid is 0, right? An infinitely long solenoid.
Here it is 0. Along this I found out and showed to you it is at par with a bar magnet. Equivalence between bar magnet and solenoid. Bhulna mat, that's very important. $16. Not fair. 16th I have done in the class again. All the people who have asked these problems, which I have done in the class, you don't open your class notes after going home, is it? कभी खोलते नहीं आप लोग. See the diagram and tell me if I have done this or not.
Yes, sir, you have done that.
Is there any batch where I have forgotten this? Theta, d theta. This is r d theta. This will be df. This will be df cos theta, df sin theta.
So we integrate
What is
df.
more surprising is 20th also is a doubt. Didn't I deal with that in the class? जिसका भी
So you
20th
did it.
doubt है, please tell me if I have forgotten in your batch. Please speak. 20th, have I forgotten in your batch? क्लास नोट्स खोल के देख तो लो, जिसने भी 20th पूछा है क्लास नोट्स में है कि नहीं। हाँ या ना कुछ बोलो, मुझे आगे बढ़ना है।
सर ये वो क्यूब वाला है ना?
हाँ 20th डायग्राम देखो, क्यूब दिख रहा है कि क्या दिख रहा है आपको? $5 मेरे अकाउंट में लिख लो।
So, then 22nd I have conceptual doubt. So अगर like हम लोग जो है Q/2m जो है use करते हैं, we do it only for the like the entire surface is covered with charge uniformly, or if any like anything, if any part is covered with charge.
Any body, मगर सुनो ध्यान से, any body will do, regular, irregular, structure, anything, but only one condition. Mass Q/2m में mass will be only that of the charge. Mass will be only that of the charge. Additional mass में नहीं दे पाऊँ।
So what?
Q/2m में जिस पार्टिकल का चार्ज आपने लिया है, उस पार्टिकल का मास विल कंट्रीब्यूट टू द मास ऑफ द बॉडी। आप अगर ओरिजिनल डेरिवेशन भी देख लेंगे, व्हाट डिड आई टेक? आई टुक ए रिंग। याद करो, रिंग पर देयर वाज पॉजिटिव चार्ज, राइट? You have charge Q on this. Q/2m is mu by L. M was mass of the charge. I didn't add additional mass of the ring to it.
Okay.
M was mass of the charge. Do you get this point clear?
Yeah.
सर m तो कट जाता है लेकिन
Pardon?
m कट जाता है ना if you write l as I omega in most questions it gets cut.
Why mu by L is Q/2m ना यार?
हाँ I was saying कि that m gets cut out later on.
क्यों कट ऑफ होगा भाई? Q/2m m आएगा, m is the mass of the charge.
So L so वो mu निकालने की बात कर रहे हैं, उसमें कट होगा।
क्या बोल रहे हो आप लोग? Here this is rotating with an angular velocity omega. Mu is I into pi r square. I is Q by 2 pi by omega into pi r square. L is I omega. This I is moment of inertia. This is because of the charge mr square into omega, right?
वही बोल रहा हूँ।
अरे
ये
सर वो
कहाँ कटेगा? यहाँ आ रहा है ना यार।
Not like that, sir. He's saying that like to derive mu from this equation, then m will get cut.
सर वो बोल रहा है L का वैल्यू डालेंगे तो फिर M कट हो जाएगा दोनों साइड से।
Obviously, that we are not debating at all.
So 22nd वाले क्वेश्चन में जो फिगर है उसमें applicable होगा, right?
Q is uniformly distributed over the slant surface of a right circular cone of semi-vertical angle theta and h. Cone is uniformly rotated. Calculate the associated magnetic dipole moment. As simple as that. Mu by L, Q/2m. Now bring L to the numerator. Mu पूछ रहा है वो. Q/2m. L is I omega. Moment of inertia for cone substitute करो. This is 2 pi by t. Now keep it as omega. ठीक है ओमेगा, राइट?
Yes, sir, but integrate करने से like same answer नहीं आ रहा है।
क्यों नहीं आएगा?
सर
थोड़ा
एक्स्ट्रा
एक
sec theta
extra
ऐड
term
ऑन
आ
होता
रहा
है।
है।
बिल्कुल नहीं,
So
बिल्कुल
can you do
नहीं।
it and show?
2-3 बार
$100
integrate करें।
रखो वहां, मैं सिंप्लीफिकेशन करूंगा।
सर
अभी
आता
के
है
अभी
उसका भी।
सब काम छोड़ के करूंगा।
मेरे 50-50
हाँ सर चलेगा। 2-3 बार सर किया सर, बार आता है।
सर आता है उससे, इंटीग्रेशन से भी आता है।
एक ही गलती किया हुआ होगा आपने। कोण लेने पर This is slant height. If I take this y as this and dy, this will be dy by cos theta, the slant height.
सर ये किया था.
हाँ तब तो आएगा 200% आएगा.
सर डिनोमिनेटर में लाइक sec theta मतलब cos theta मल्टीप्लाइड होता है, एक्स्ट्रा टर्म आता है cos theta.
हाँ एक्स्ट्रा cos theta.
How many of you are getting extra cos theta? Raise your hands.
रेट करने पे आता है.
हाँ 3.
When we substitute sigma by is q by area तो उसमें एक sec theta का टर्म आता है.
फालतू में कौन का करवा रहे हो यार मुझसे. 22nd, right?
Yes, sir.
You have positive charge all throughout this particular body. This is of radius r, height h. What are all the parameters given? Q charge is distributed over the slant surface of a right circular cone of semi-vertical angle theta, height h. Theta is given, height h is given. Theta is given, height h. Radius is not given. Cone is uniformly rotated with an angular velocity omega, and your requirement is mu by L, right? Mu. You should find out the dipole moment. Do you remember the formula for dipole moment of the ring?
Yes, sir.
Dipole moment of the ring. I don't remember, hence I'm turning the pages of
Sir, I pi r square.
Yeah, I pi r square हर कोई बोलेगा. I pi r square. Dipole moment of the ring कितना है? मुझे याद नहीं, तुम लोगों को भी अपने अच्छे बच्चे.
Q omega r square by 2.
हाँ, how much?
Q omega r square by 2.
Can you bank on it? Now consider an element. Consider an element. This is rotating with an angular velocity omega. D mu is dq omega r square by 2. How do I get dq? Sigma into, this is smaller, sigma into 2 pi small r into, you considered this as y, this as dy. 2 pi small r into thickness dy by cos theta. This thickness is dy by cos theta. Am I right? This is dy, this is y. This into omega square r square by 2. We have to eliminate small r in terms of y for us to integrate. Small r by capital R is y by h. Small r is y capital R by h. This will be sigma. This 2 will get cancelled. Pi r dy by cos theta. This length is dy by cos theta, right? Yes. Omega square r cube sigma pi r is y capital R by h whole cube dy by cos theta into omega square. This is d mu. Say something. Till here, is everybody clear? Am I on the right track or am I committing a mistake? कुछ तो बोलो.
Yeah, that's right.
Till here, fine. Now, sigma is charge. Did he give you Q? What did he give you? Q.
He gave us charge.
Curved surface.
Pi.
Pi r slant height is L. Now once again I'll have to eliminate that. pi r cube by h cube, right, into omega square by cos theta. What all did I miss? Pi r cube by h cube, omega square by cos theta. This will be y dy. This will be mu.
So y cube, no?
Y cube किसलिए भाई? Here it is y cube. Perfect.
So also sir r भी आपको eliminate करना है capital R.
Pardon?
Capital R भी eliminate करना है सर, वो question में नहीं है.
Capital R eliminate करना है ना, वो eliminate कर लेंगे. Pi, this will go. That won't be an issue. D mu is equal to Q omega square R square by L H cube cos theta y cube dy. Till here is the simplification okay?
But it should be just omega, not omega square.
Omega square यहाँ क्यों आया तो? Why did I write omega square here? This was dq, right? So it is omega. Is it by mistake that I am carrying omega square?
Yes sir.
Now, slant height L is not known. I need in terms of h and capital R. Capital R is given or not?
No, h is given, height.
H
So
and
cos
theta.
theta is h.
Cos theta is h by L. Cos theta is h by L. But then we need to keep cos theta because that's given. But either way, what formula will you use for moment of inertia? L is equal to I omega. What is the I value for the cone?
mr square
mr square by 2.
M R square by 2. Right? So bring everything in terms of R. Bring everything in terms of R. Cos theta. Do you know the formula in terms of H? Moment of inertia formula in terms of H, do you know?
r is
No,
equal
but-
to
R by H is tan
theta.
theta ना R
Sir
R is equal to h tan.
h tan theta लिख के
R
h
is
square
H
tan
tan
theta
theta
बना
लिख दो.
क्या दिमाग लगा है यार, R is equal to H tan theta लिख दो, डिराइव नहीं करो और आप फॉर्मूला नहीं बताएंगे. हाँ.
So m by 2.
I remember mh square by 12 vaguely.
So m h square tan square theta by 2 into omega. So the answer is theta in it, right? What-
That theta will get eliminated from this. It should be both the hey, R, L and H का एक पैरामीटर में ले आओ. Okay, you will tell me only in terms of R. Well, let's do it in terms of R. H, how do I substitute? Tan theta is equal to H by R. Am I right? Sir, tan theta is R by H. Agreed? Say something.
Yes. So get everything in
Yes.
that, no?
Q omega. Now I'll eliminate H. H is R by tan theta. R square. L. H is R cube by tan cube theta divided by cos theta. Y cube dy. Right? Is the simplification correct? Now theta we will handle. First of all, get rid of L. How do I get rid of L? Cos theta is, no, sin theta is R by L. Sin theta is R by L. L is equal to R by sin theta. L is equal to R by sin theta. Now R square and this will go. I'll be left with R square. Q omega tan Q omega by, I have an R square rather. This is tan cube theta divided by cos theta y dy. Q omega by R square tan cube theta cos theta. Now R also I need to eliminate.
So you missed sin.
तो sin theta छोड़ दिया.
It's y cube. Sin theta, cos theta and y cube. Am I right?
So should it
cos
be
theta
sin
by
theta ऊपर? Sin theta ऊपर
Sin
होना
theta will go in the numerator.
Okay. So that means this will become tan to the power
tan raised to 4
theta.
theta कर दो.
Who said they are getting theta in the denominator?
सर वो सर cos थीटा नहीं sec थीटा आ रहा था सर. सर लेकिन आई थिंक आपने थोड़ा कुछ किया है. सर मैं आपको अपना डेरिवेशन भेजूं क्या?
मुझे तेरे डेरिवेशन से क्या लेना है? इसमें गलती बोलो. Somebody is asking where is L? L भूल गया क्या मैं? L substitute किया ना यार. L is R by sin theta. सो रहे हो आप? L is R by sin theta. Sin theta is R by L. L is R by sin theta. वही तो substitute किया यहाँ. Right. Now listen. You will have to bring tan theta in terms of y.
So नहीं so tan theta तो constant है.
Tan theta is a constant. Okay, then integrate this. Did we get all the symbols? Capital R is a constant. Should we keep capital R? Yes, because it should get cancelled out. Right? This you will have to integrate. Y is from 0 to h. Eliminate h either in terms of theta or r, and then tell me whether you are getting the last step answer or not. Somebody last two step simplification करके बोलो जल्दी करो.
सर आपने जो किया उससे आ जाएगा. सर मैं एक सेकंड सर मुझे मेरे इसमें समझ नहीं आ रहा मेरे इसमें क्या
मुझे 100 US dollars बोला था ना यार. How many people were ready to share it?
सर
Hey, चुप रहे. 100 US dollars. How many people? Raise your hands. People who are ready to share that. एक ही बच्चे ने शेयर, अब दूसरे ने बैक.
सर WhatsApp देख लो.
हाँ, अब बोलो मेरिया.
तो मेरे को सर मैंने कहीं तो सर आई थिंक मैं अपना सॉल्यूशन आपको बाद में भेजता हूँ सर क्योंकि मेरे को वो सही लग रहा है लेकिन मेरे को पता नहीं मैंने कहाँ मिस्टेक की.
ये समझ में आ गया?
हाँ सर बट
that's the end of the story. 100 US dollars. लेट करोगे तो 1000 हो जाएगा. जल्दी लिखो, make it fast. These are all crazy simplifications here. They consume time, but for that nothing. कौन है भाई? 100 US dollars का फोटो भेज रहा है मुझे. जिहान दफ्तरी, मुझे 100 US dollars का फोटो भेज रहे हो.
सर आपको 100 US डॉलर्स थे तो भेज दिया.
टोपी पहना दो मुझे. राइट, तेरा आवाज पहचानता हूँ मैं.
जिहान फेमस है.
अगले क्लास में आना, हिसाब बराबर कर दूंगा. टोपी पहनते हो सफेद कलर की. हाँ, can I have the board? कुछ तो बोलो.
Yes, sir.
नेक्स्ट नंबर क्या दिख रहा है? 26. A very small circular ring R carrying the current I1 is placed in the xy plane with its center at x-axis at the point C, center on the x-axis. Square loop of side 2I carrying current I2 is fixed in the y-jet plane with the center of the loop at the origin. Torque exerted by the square loop on the circular. Okay, do you know the magnetic field due to the square loop? Square loop के वजह से find out the magnetic field here. Right. dipole moment of this, and magnetic field will be somewhere this way or inverse. Square loop के वजह से magnetic field कैसा calculate करो यार? Sin 45, sin 45. Yes or no? Torque will be mu cross B. ये problem जिसका भी doubt है, will this hint be sufficient or do I have to solve? Because of the square loop, magnetic field is like this. Dipole moment for this will be like this. They are both perpendicular. So technically it will be I into pi small r square B into sin 90. All you have to tell me is the value of magnetic field at the center.
So the square loop is in the YZ plane, right? And the ring is in the on the x-axis.
Y, Z. This is x-axis. This is the ring. Right? So they are perpendicular. This is the x-axis. Ring is like this.
Yes, sir.
Right? Square loop is center is at the origin. ऐसा बोला हुआ है. Square loop or silent carrying is fixed in the YZ plane with the center of the loop at the origin. Fine. Listen. Have we done this problem for square loop magnetic field along the axis?
Yes.
Yes.
Yes, magnetic field ka value le lo yahan. Now what he is saying is this is a circular loop and the square loop is in the YZ plane with this at the center. That means if the square loop is like this, here this is YZ plane, x-axis is this way. यहाँ पर circular ring रखा हुआ है. Right?
Yes, sir.
No, so that would make it in the XZ plane. It's in the XY plane, so it's horizontal.
So you mean to say circular ring is
Yeah.
kept?
Yeah.
Yeah, right. The circular ring is kept this way, not this way. Why this way? Only then theta is 90. Right?
Yes, sir.
Where am I? This was 26. 27. Square coil is mounted on a fixed insulating axis passing through the midpoints of a pair of opposite sides. A very long straight conductor parallel to the axis and at a distance of 12 centimeters from it is carrying a current of 65 amperes. When the coil is in the position in which its opposite sides are parallel to the axis and equidistant from the long straight conductor, find the torque acting on it. Current of 78 amperes. No, have a look. This is the genuine doubt. This is the wire and this is the loop. This loop is perpendicular to the plane. This loop is perpendicular to the plane. थोड़ा ध्यान से देखिए, this 3D visualization is difficult. This is the axis. This is the current carrying wire. And this is the rectangular loop.
Yes, sir.
Agreed? Agreed?
Yes, sir.
Now,
Yes, sir.
force on this side and the rectangular loop. I only explain the problem. पूरा simplification नहीं करूँगा. ध्यान से सुनिए. This is a wire. This is a wire. Can you tell me the force of attraction or repulsion between them both?
Yes, sir.
Direct formula.
Yes,
Yeah,
yes,
sir.
sir. Yes, sir.
Yes, sir.
Similarly, can you find out the force between this other side and this?
Yes, sir.
No. Till there you are safe. Your problem comes when I am dealing with the upper end of the wire and lower end of the wire. Upper end of the wire, lower end of the wire, अगर मैं ऊपर से देखूंगा, if I see from the top, the diagram will appear this way. If I see from the top, I'll assume this is a cross. This is a cross. Right? This end of the wire will appear like this. This distance is known. This distance is known. This end of the wire will appear like this. This is a cross. Current is going inwards. Magnetic lines of force will go this way, clockwise, and draw it once again, keeping it clean. Observe this. This wire is a cross, right? I draw magnetic lines of force like this. Now this is the wire. Here the magnetic field is this way. Here the magnetic field is this way. Do you agree with that? This wire is this. You are showing this wire here. If I tell you how to solve for this, it will not be difficult for you to solve for this. Do you agree with that?
Yes, sir.
Yes, sir.
Now, this magnetic field curve, I will take this to be theta. This is 90. So what will this angle be? Doesn't matter for me. B cos theta, will it produce any force on that segment of the wire?
No.
B cos theta is along the wire. Will B cos theta produce any force on that wire?
No.
No.
Now B sin theta will produce a force on that wire. Agreed?
Yes, sir.
Yes, sir.
Now force on this particular wire, B sin theta is downwards, F, B, I. Force on this part of the wire will be perpendicularly into the board. F, B, I. Have a look at this. Thumb is the force, forefinger is the magnetic field, middle finger is the current. I'm taking current in this way. Now, exactly the same way, I will calculate this particular force here. If I take this as theta, this is theta, this will be theta, this will be 90 minus theta. Now, this will have a vertical and horizontal component. The horizontal component will not produce any force. Vertical component will produce a force. Vertical component will produce a force. F, B, I. Force will be outwards. That means to the right segment, force is inwards. Left segment, force is outwards. Can you calculate the torque on that element?
Yes, sir.
Do the same thing for the lower element.
Okay, sir.
Now, why will you not calculate the torque due to these both here? Force due to these both are passing through that axis to the wire. I have given you the hint. Make a note of it and solve this. It will take 5-10 minutes to do the simplification. Once again, the physics involved is very, very, very minimal here.
Why wouldn't the side ones produce torque?
Side ones ka force resolve karo. One force will be passing through this axis, one will be passing perpendicular to the axis. Only the perpendicular component will produce a force on it.
The perpendicular component will not. No.
Huh.
Okay, okay.
Right. This force ka, this component.
Yeah,
There is force this way. It's this component and this component. This component will pass through the axis.
yes.
आपको इंटीग्रेशन ओनली फॉर द अबव एंड द लोअर वन करना है. These two के लिए इंटीग्रेशन नहीं करना है. Force is constant at that instant.
Sir, about which axis do you have to find the torque?
Take about this particular axis. It turns out to be a couple that you will realize after simplifying. And torque due to a couple about any axis will be the same.
Yes.
Oh. So.
Huh?
So ये जो top वाला part का है, wouldn't the force be parallel, like the force, the down wala component, it will be parallel to the axis? The
Yes, sir.
Are they getting cancelled out?
No, so but like one is up and one is down, but aren't they parallel to the axis and won't produce any torque?
If they don't produce a torque, fine. You will get the answer to be zero if they don't produce a torque. After adding them,
Okay.
I don't know the answer. Hence I simplified. Rather, I put that on the book. Because I didn't do the
Sir, answer is not 0.
Pardon?
Answer is not 0.
They won't produce talk around about this axis. They'll produce talk about some other axis.
अब नया कंफ्यूजन मत करना, जो है सो है, सिंप्लीफाई कर लो, जो आंसर आएगा.
Okay, sir.
है क्लास में किया हुआ है. 28. Didn't I deal with this? This is small r, this is capital R, this angle is phi, phi. You took the torque about this axis, x dash. You took the force on this at a distance of x. You took this to be dx. The magnetic field is like this. You found out that torque on this is perpendicularly inwards, torque on this is perpendicularly outwards. You took this to be x sin phi. Beta is equal to p I dx into x sin phi. This you integrated. किया है कि नहीं मैंने क्लास में?
सर किया है क्लास.
Somebody said 24th as well. 24th torque is mu cross B. 24 torque is mu cross B. Right, angle if I am right will be 30 degree between the area vector. How do you want me to get area vector? Curl your fingers in the direction of current area vector you will get. If I remember well, that will be 30 degrees. I into A into B into sine 30 is the answer. Frame carries a current I and is free to move around its upper side. Compute the magnetic field in the positive y direction. Frame is along the positive z direction, right? Required to hold the frame tilted 30 degrees away from the vertical. So guys are mu cross B should be equal to mg into something else sin theta. A, right? A is that side A? A by 2 sin theta. Simple. Have a look. Your loop is like this. Vertical magnetic field is there. So the area vector, let me assume, is like this. Magnetic field is like this. In dono ke beech, can you find out the angle? Say something.
Yes, sir.
Yes, sir.
This is magnetic field, this is area. Angle between them you will be able to find. So will you get the torque mu cross B?
Yes,
If you
sir.
get the torque mu cross B about this axis, you will take mg, whole of weight of this is act at the center of mass. Mg into this perpendicular distance, mg into perpendicular distance will be this from this axis. Yes or no? If I draw this
Yes,
this way, the loop like this, it is going perpendicular to the board. This will be mg into perpendicular distance is this, about this axis. Mg into this perpendicular distance. Right? Equate both. All you have to visualize is the angle between area and magnetic field. अगर वो visualize कर दिया, torque due to mg, torque due to mu cross B are balancing each other. Person who had this doubt, have I addressed your doubt? Will you be able to simplify further?
Yes, sir.
$31. A coil of radius I1, another coil of radius small r, much lesser than capital R, carries I2. Plane of the two coils are mutually perpendicular, free to rotate about a common diameter. Find the maximum kinetic energy of the smaller coil when both coils are released. Listen, 31 May, one coil is kept this way, another coil is kept this way. They are free to rotate about this axis. Right? Now, firstly, this coil is I into pi small r square. This coil mu is equal to magnetic field because of the other. B is equal to mu naught I by 2 capital R, but that will also have a dipole moment. This will also have a dipole moment. Capital I into pi r square. Now, what is the initial potential energy? Minus of mu dot B. Mu for this is I into pi r square. B is mu naught capital I by 2r into cos 90 mu dot B. For this, mu is this, B is this, cos 90 degree. Do you agree with this? Mu of this is in this direction, B is in this direction. Initial potential energy will be this. He asked you final potential energy or they're mutually perpendicular to each other initially. Perfect. So this is the dipole moment, this is the magnetic field. No issue with that, right? Till here, is everybody clear?
Yes, sir.
Now you final भी calculate करना है आपको. U final.
Maximum kinetic energy.
Right. When they are in the same direction, mu and B minus mu B, mu dot B, I into pi r square, mu naught I by 2r into cos 0. Will this difference be maximum? Will
Sir,
this
we need to conserve angular momentum also, right? The larger
one
angle
second,
also.
one second. Firstly, can we do this? Loss in potential energy should be equal to gain in here. Angular momentum भी conserve करना पड़ेगा. We will come to that. But first of all, when loss in potential energy is maximum, then that maximum will be gain in kinetic energy. Half I1 omega 1 square plus half I2 omega 2 square. Problem is, both the rings में any one of them is not fixed. This will also rotate. This will also rotate. So now the necessity for conserving angular momentum will come because there are two omegas. Now when there are two omegas, there is no external torque. I1 omega 1 minus I2 omega 2 should be 0. Initial value. This is the first equation. This difference I equated to this change in angular momentum. Initial and final should be equal. When did I find the necessity for conservation of angular momentum? When I find two omegas. Is this point clear?
Yes, sir.
Two equations, two variables. Why did you take cos 90 and cos 0? Cos 90, the initial situation given. Cos 0, final you decided, because maximum difference in potential energy will give me maximum kinetic energy.
सर ये नहीं करे सर, मतलब मैंने नहीं किया तो सर अप्रोक्सीमेटेड आंसर आता है जो पीछे दिया है, मतलब उन लोग ने r जो है वेरी मच मच स्मॉलर देन r दिया है तो उससे अप्रोक्सीमेट करो तो अप्रोक्सीमेटेड सेम आता है उसका आंसर.
You will have to say whole of that again.
सर पीछे जो दिया है सर उसको अगर अप्रोक्सीमेट करो तो अगर आप ये नहीं करो तो सेम आंसर आता है, लेकिन ये करना पड़ेगा अगर सेम आंसर.
That's okay. Once you see the 4 options in the exam, you will directly be able to make a guess.
Yes.
Sir, in the Feynman's paradox, we had seen that even magnetic fields have angular momentum. So do we have to
I
account
was
for it?
waiting for somebody to hold this mistake. These problems are developed and designed in quota. This problem conceptually should not be given. You are conserving angular momentum between two rings. There is no 100% assurance that this will be right. Because angular momentum conservation, when you do, you will have to take the angular momentum carried by the magnetic fields of the two rings.
Yeah, sir.
Not the two rings. Why this flaw? Because basically this problem is developed and designed in quota. By chance, any of the test series give you this question, solve it this way. You'll get marks. After getting into engineering, think twice before doing such a thing. Can I have the board?
Yes, sir.
Thirty-three. I draw the diagram. You see that will be a hint. I have solved this in 3 years batch, but not in the other batches. 3 years batch, I had time we did this. This was the initial loop. This angle is theta. On this, force will turn out to be this way. On this, force will turn out to be this way because magnetic field is vertically upwards. Right? Up force ka direction dekh lo. You will get these both forces this way. They both will not produce any torque about this axis. So no point of calculating this force. mg will produce a clockwise torque. This force, magnetic force, will produce an MIN BIL sin theta. BIL sin theta. Now this will give me anti-clockwise torque about this axis. mg will give me clockwise torque. mg here and mg here will give me clockwise torque. These both only will be dumped. Torque due to this is anti-clockwise. Torque due to this mg, this mg, this mg is clockwise. Equate both.
So इस क्वेश्चन में यार 30 में कुछ मतलब आधे द सेम थिंग बिकॉज़ इसके आंसर में ही मैंने थीटा को 30 डाला तो आंसर तो मैच हो गया, they looking like the same thing. This and the 30th question.
This and the 30th are almost the same.
They're
Right?
the same thing, right? Yes.
Only thing this is copyright irido, that is copyright quota.
Yeah, but they're the same thing. सिर्फ थीटा का वैल्यू चेंज हुआ है.
Yes. It's a small difference I believe. In the 30th, this side is closed with current.
So उसका torque तो नहीं आ रहा.
Huh. Hence, they both will turn out. Now, when you are taking the torque about this, even if you close the side and do it,
Yes,
the answer will turn out
exactly.
to be the same.
Yes.
Thirty-four. Listen to this carefully. Long straight wire. Now, this is again a solid example in this book, Basic Laws of Electromagnetism. by Erdo. But I would prefer to explain it in a simpler way instead of calculation, because he wants the direction of the force, magnitude and direction of the force vector applied to the loop if the vector is Pn. Right? So first of all, if this is the direction of mu, force you people know how to calculate. How will I calculate the force? You know the magnetic field here. Because of the wire, do you know the magnetic field? Mu naught I by 2 pi r. I am taking this distance to be r. It is perpendicularly into the board. Find out the potential energy minus mu dot b. F is equal to minus du by dr. This is the way you calculate the force. This part, is it clear to all?
Yes, sir.
Now, direction के लिए देख लो. Direction generally mathematically can be done, but much easier way to look at it. This dipole core, replace this with a bar magnet of north pole and south. Mu and capital N should be the same. Now, because of this, magnetic field on this is inverse, magnetic field on this is inverse. Force on the north pole will be perpendicular to the board, force on the south pole will be perpendicularly out of the board. Net force on this, don't you think, will be equal and opposite?
Yeah, sir.
Right? Contrary to that, if the ring is placed this way with the dipole moment, now place north pole and south pole this way. Now here, magnetic field here and here is the same, but then there is some length for this. So the two forces will not be equal. So there will be a net force on it. Yes or no?
So, but
Sir, can you please solve the B part?
So can you
Sir,
just
can
solve the
you-
B part?
See,
only that.
coincides in direction with the magnetic field produced by current at a point where the loop is locate.
Sir, B part.
So B part.
A. C या B, Bombay or Chennai?
Sir, B part using minus mu by dr.
Bombay, right? Okay. Small current carrying loop is located at a distance of small r from a straight conductor with high magnetic moment of the loop is Pm. Find the magnitude and direction of the force vector applied to the loop if the vector is oriented along the radial direction. Vector is oriented along the radial direction. So he called Pm, I will call it mu. Right? So now magnetic field is perpendicularly inverse. Magnetic field minus mu dot B minus mu. Okay, you mean to say you are getting cos 90 0.
Yes, sir. So पीछे zero नहीं दिया है और.
Yes, sir.
Obviously zero नहीं होगा. Potential energy zero हो रहा है मगर rate of change of potential energy is not zero.
हाँ, so तो इसलिए problem आ रहा था इसमें solve.
Listen, potential energy is zero. Have a look at this. Exactly the way we have dealt with two electric dipoles this way.
Yes, sir.
Right. So here, do one thing. Find out the torque on it. Torque is mu cross B. Mu is kept as it is. B is mu naught I by 2 pi small r into sin 90. This is equal to R cross F. Mu, he called it Pm. Mu naught I by 2 pi r squared. What is the answer given behind?
और ऐसा ही दिया.
Why did you not use potential energy here? Recollect, I taught you this in electrostatics. Velocity can become zero, but not rate of change of velocity. Whenever velocity becomes zero, think twice before saying acceleration is zero. Here, potential energy is becoming zero, but rate of change of potential energy need not be zero. How did you clarify that? Take the torque on it, from torque calculate F perpendicular. This is what Erdo himself does. It's not our idea. Idea as it is picked up from basic laws of electromagnetism.
So
this is part B and C both, right?
जो भी
Same answer है, but direction change होगा.
सर आप जो कह रहे थे लाइक मतलब इस पोजीशन में रखा है तो आप बार मैग्नेट को वो कर रहे थे तो इक्वल फोर्स नहीं होगा, लेकिन वो तो शॉर्ट बार मैग्नेट है ना, तो उसमें तो इक्वल फोर्स होना चाहिए.
लिमिट समथिंग टेंडिंग टू जीरो एंड इक्वल टू जीरो में फर्क आज तक आप लोगों ने नहीं.
नहीं 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 सर, बट अगर आप इसको लाइक लूप को ले रहे हो तो लूप में तो जीरो ही लेना पड़ेगा.
क्यों लेंगे भाई?
लूप में लाइक लूप में जीरो.
अगर लूप का सफिशिएंट थिकनेस है, a ring you that you take infinitesimally thin ring and the ring of certain thickness. क्यों? एक सर्कुलर लूप का थिकनेस हो सकता है.
ओके ओके समझ.
One second, wait. I'll show you that solution as given by Irva. It will be This is the book I'm talking of, Basic Laws of Electromagnetism. छोटा सा book है. Now don't spend your time reading this. It doesn't make sense. But sometime when you're free after getting into IIT, you can think of looking into it.
सर कॉलेज में तो पढ़ना ही पड़ेगा ना.
नहीं, ऐसा नहीं. कॉलेज में आप लोग पढ़ते नहीं, डोंट वरी. दिख रहा है?
Yes, sir.
Yes, sir.
Solution as
Yes,
given
sir.
by him. He only discussed this. Incremental value. We conveniently write the torque expression. They give it in terms of description. dB by dt direction. All three direction of forces भी दिया हुआ है. After the class, I'll take a pic of it and send this to you. उसका explanation पढ़िए. It will be slightly different from what I did. Right? I'll send a pic of it. This will be interesting enough. Locus of the loop से लेकर pic of the, locus of the loop से लेकर he will take it. It will be slightly strange, but I would suggest go by this. Can I rub the board?
Yes, sir.
Yes, sir.
I discussed the 34 right now. 35. The loop is placed thin wire, mass, rotate, friction, O dash passing through right angle. The loop is placed in a homogeneous field with an induction of B directed at right angles to the plane of the drum. Current I is passed in the loop. Find the period of small oscillations that the loop performs.
Sir, that's 36.
So what am I reading? 36 is the pattern.
Sir, 35 लिखा है बोर्ड पे.
Find the interaction forces of two coils with dipole moment. The separation between the vortex is considered with the linear dimensions. Hey, here dipole moments are constant. 35 जिसने भी पूछा है mu naught by 4 pi m1 m2 by r to the power 4. This was taught to you people. If m1 m2 are constants, you can use this. Yes or no?
Yes, sir.
कोई कुछ बोलेगा? $39.
Sir, 6 by 4.
Pardon?
It should be multiplied by 6, no?
So 6. I forgot this. You are right. $39. A beam of equally charged particles are being accelerated through a voltage V enters the magnetic field at D as shown. It is found that all the particles hit the plate between C and D. Find the ratio between the masses of the heaviest. C का radius is L. mv by dq. D का radius is L plus D. It is entering at A. All the particles enter into the magnetic field as shown in the figure. Radius is L plus D. L plus D will be mv by bq. Now q by m for all the particles. V by b. I call this q by m here. Right? V by b, q by m. All the particles are entering with the same speed.
No.
It's the same kinetic energy, no? QV same.
1 second. 1 second. Hey, 1 second. We'll disconnect. I'll get back to you people. We'll finish the next 1 or 2 problems along with HCV. See you people. Good night.
Bye, sir. Thank you.